Hello everyone, and welcome to my presentation, Narrate to Educate, all about the modality principle. This is for my course EdTech 513, and the creators of this presentation are Maddie Lowe, Sydney Kuharik, Brianna Colmer, and Robert Yasakochi. Let's get into it. What is the modality principle? The modality principle states that people learn more effectively from graphics and spoken words rather than from just graphics and printed text. This principle is grounded in cognitive science. When learners hear narration instead of reading on-screen text, they can better process visual and verbal information together without overtaxing their visual memory. So what's inside this presentation? First, we're going to start out with the principle guidelines, and then we're going to move into supporting psychology, then on to research evidence, and then finally principle use with some examples. Principle guideline overview. The modality principle states that words should be put into spoken form rather than printed text whenever a graphic is the main focus. These graphics can be animations, videos, or a series of static frames. The modality principle is not an ironclad rule, however. For example, a few well-placed words related to the graphic being presented do not violate the modality principle. In the next slides, more exceptions to come. The exceptions. The main exceptions to the modality principle, where printed words should be presented alongside spoken words, are as follows. The words are unfamiliar. Learners have zero prior knowledge with the words or subject. When the vocabulary used is technical jargon. When the words are not in the learner's native language. When learners control the pace of learning. When the amount of words is large. And finally, when the information presented will be presented again later. The exceptions for the modality principle can generally be separated into two separate groups. The first group of exceptions are related to the complexity of the information being presented. The three exceptions that fall into this category are technical language, unfamiliarity, and native language. First, technical language or jargon that relates to a specific field often contains words and acronyms that learners may not recognize. Technical language also sometimes uses words and acronyms with a specific meaning that can mean something completely different when relating to another field. For example, a mechanic may use the acronym ABS to refer to anti-lock braking system, while a medical professional may use ABS to refer to the American Board of Surgery. Moving into the second category of unfamiliarity, this relates to the level of prior knowledge the subject being presented is possessed by the learner. If learners have little or no prior knowledge on the presented subject, then it is likely that the vocabulary being used will be unfamiliar to the learners. Moving on to the last category, we have native language. Information being presented in a language other than the learner's native language also presents a situation where the vocabulary will be wholly unfamiliar to learners. Since learners will not be familiar with the vocabulary, it is best to present the words as written text so learners have the chance to familiarize themselves with said vocabulary. The most common example of this in the U.S. would be native English speakers learning Spanish in primary and secondary schools. Exceptions for sequencing. The second group of exceptions are generally related to the sequencing of information being presented. The three exceptions in this group are pace, large chunks, and referencing. Starting off with pace, if learners are in charge of the pace at which they are consuming the content, then it will be beneficial for printed text to be printed alongside audio. An example of this may be a presentation provided in an asynchronous course. Moving on to large chunks. Large chunks refers to how much information is being presented at once. If the script for the information being presented alongside a graphic is long, then presenting printed text alongside audio reduces the necessary load on learners' working memory. An example of this could be a movie for a media interpretation course where subtitles are enabled. Lastly, we have referencing. Referencing refers to when the information being presented will be referenced later. The most common example of this would be a process with multiple steps. Moving on to supporting psychology, we have that the modality principle prevents cognitive overload. Cognitive overload can occur if too much on-screen text is used with visuals. The brain will have trouble categorizing the information in the visual channel, and this can lead to unnecessary extraneous processing. When your brain sees too much on-screen text in combination with graphics or visuals, it's like a game of tug-of-war. On one end of the rope, we have visuals demanding the brain's attention, and on the other end, we have the text demanding the brain's attention. This back and forth can fatigue the brain and cause cognitive overload as the brain attempts to process too much information simultaneously. This supporting psychology is backed by cognitive theory. Cognitive theory supports the use of the modality principle in psychological processing and new knowledge integration. Cognitive theory supports the claim that information presenting coupled with cognitive processing is responsible for learning. This theory also claims that humans have separate channels for processing. These two channels are the pictorial or visual channel and the auditory channel. Think of these channels like highways to the brain. If we only have one lane highway for many cars, then traffic will be stagnant and delayed. But if we add in another highway, cars can begin to move at a faster pace and that congestion will be resolved. This is the same for our processing channels. When we look at text and graphics together, they are using the same visual channel, which can lead to cognitive overload. But if we add in that auditory channel, we are able to allow our brain to categorize information better and prevent any traffic jams in cognitive processing. This short video offers a quick, clear example of how narration paired with visuals improves understanding.
There is strong evidence that using words and audio instead of in text along with graphics can significantly improve learning. When we engage both the auditory channel and the visual channel with the use of graphics, the brain can accommodate more information. And by minimizing strain on their dual channels of processing, we can help maximize what students learn and retain.
Research evidence to back the modality principle can be exemplified in a study done by Mayer and Moreno in 1998. In the study, the words in the narration and the on-screen text were identical, and they were presented at the same point in the animation. On a subsequent test in which students had to solve transfer problems about lightning, the animation with narration group produced more than twice as many solutions to the problems as compared to the animation with text group, yielding an effect size greater than 1. Consistent with cognitive theory, eye tracking studies found that students who viewed animation with narration on lightning formation spent more time looking at graphics than did students who received animations with on-screen text. Students performed better on transfer tests when words were spoken rather than printed. Moving on to a study done by Mayer and Pilegaard, 2014. This was a large-scale review of published research articles that used topics across STEM and technical training, including environmental science, biology, and aircraft maintenance. The review found a median effect size of 0.76, showing a strong benefit of narration with graphics. Students who received narration and graphics consistently scored higher on transfer problem solving than those who received on-screen text and graphics. The effect supports cognitive theory and the dual channel assumption. Reducing overload on the visual channel improves retention and application. This research validates the modality principle across many content areas and learning settings. Let's begin by looking at examples that violate the modality principle. In this e-learning lesson slide, we see a diagram of a human heart accompanied by a block of text explaining how the parts work together to pump blood throughout the body. At the same time, a narration plays describing the same process. This slide violates the modality principle in several ways. First, the visual channel is overloaded because the learner must process both the diagram and the on-screen text simultaneously. Since both the image and the text compete for the same visual processing resources, the split attention can reduce comprehension and increase cognitive load. Additionally, the narration is lengthy and unsegmented, exceeding what learners can comfortably hold in their working memory. As a result, they may forget earlier information before they've had a chance to integrate the later parts. And finally, although the narration uses technical terms to describe anatomy, there are no on-screen cues to support decoding or retention of these unfamiliar words. Without visual reinforcement, learners may struggle to follow along, especially in the terms that are complex or difficult to pronounce. To improve this e-lesson and align it with the modality principle, several key changes should be made. First, the large block of on-screen text should be mostly eliminated. Instead, key terms can appear briefly as labels, synchronized with the narration, and highlighted on the diagram. This approach supports the visual channel without overloading it, and helps guide the learner's attention to the relevant part of the graphic as it is being explained. Second, the narration should replace the written explanations. By presenting the content as audio, the learner's visual channel is freed up to process the graphic, while the auditory channel handles the spoken words. This split between visual and auditory processing reduces cognitive load and improves comprehension, especially when complex or fast-paced visuals are involved. Third, the narration should be broken into short, manageable segments. Segmenting the content ensures that learners, particularly those with low prior knowledge or working memory, are not overwhelmed. This allows them to absorb and integrate information at a comfortable pace without overloading either channel. Finally, for technical or unfamiliar vocabulary, it's important to briefly display the printed term on screen while it is spoken. This dual presentation helps learners connect pronunciation, spelling, and meaning, reinforcing retention and comprehension. Q&A session. Let's see what we've learned so far. First, why is it problematic to include long, unsegmented audio narration in a lesson? A. Learners might prefer reading. B. Audio cannot explain technical content effectively. C. It can overwhelm the learner's working memory. Or D. It can cause the visual channel to overload. The answer is C. It can overwhelm the learner's working memory. Question number 2. What is an effective way to help learners connect pronunciation and meaning of technical terms? A. Repeating the term in audio twice. B. Displaying the word while narrating its pronunciation. C. Using simpler words in place of technical ones. Or D. Providing a printed glossary after the lesson. The answer is A. Repeating the term in audio twice. Key takeaways. Graphics and audio together are the learning dream team. There are exceptions to the rule, for example, if the concept is complex and based on sequencing. The modality principle is backed by cognitive theory, as using the auditory and visual channels in the brain simultaneously prevent overload of a single channel. Research from Mayer and Pilegard has shown that by balancing visual and auditory channels, the brain is more equipped to problem solve. And lastly, effective use of on-screen text can be displayed as short labels placed next to the graphic to avoid overloading working memory. Learners scored about 21% higher on average when they heard the information alongside visuals rather than reading it on the screen. Thank you! We hope you gained some new insight on how thoughtful design can enhance learning in digital spaces.